And I'm back. So, we just talked about the definitions that we wanted to start off with a circle, meaning where the radius is, what a diameter is, and all sorts of relationships. Let's do a few examples, quick ones, easy ones, things like that, just to make sure we understand them. So to start, let me draw myself a circle. If I remember how to draw a circle. Oh, no. Aha, wrong button. There we go. So, I've got my circle here. Great, wonderful, excellent. So, remember that a lot of times we're going to name a circle after its center. I shouldn't say a lot of times. Circles are named after their centers. So, I'm going to pick a letter N. And so, I'm going to call that circle N. And again, sometimes it'll just say circle N, or sometimes you'll see this symbol. This isn't very common, but I have seen a lot of authors do this. Circle N like that. So I have circle N, and we're going to say with a radius NP, no problem. So from N, we're going to draw out to P. We've got radius NP, and I'm going to also draw in a diameter. Diameter QR drawn here. Remember, diameter always goes through the center of that circle. Here's R. And here is my Q. All right, so let's say that NP is equal to 2x plus 5, and QR is equal to 34. And we were asked, find x. So we start off by knowing the main relationship we know between a radius and a diameter. Think of that. Try solving this one. Pause the video. I'll give you a second. Okay, so what I would do here is I would say, I know that any diameter is twice the size of its radius. So I'm going to set up and say, well, I know if I take NP, this radius, which I labeled as 2x plus 5, if I double that, I'm going to be able to get what my radius is, which is 34. So I can say take 2 and multiply it by that radius, 2x plus 5, and that should give me 34. So that means that 4x plus 10 has to equal 34. I'll subtract my 10 off. 4x is equal to 24, and dividing by that 4, x in this case gives me 6. And I'm all set to go there. So that's simple. Radius, diameter, the relationship, simple there. Now let's talk about arcs. So again, let me draw a circle. And I'll go ahead and label the center of this circle here. And picking a random letter out of my head, F, sure. Got circle F, and I'll pick 3 more letters. No, not those letters. We'll pick P, M, and F. Oh, I used F already. Then this will be E. So, I will say in circle F, the measure of arc PME I have to add in the little arc there. If I didn't, you wouldn't know if I was talking about the angle PME, that little obtuse one that would be formed there, or if I was talking about the arc. So I'm going to say the measure of arc PME is 100 degrees. And I ask you, find the measure of arc PE, or I suppose I should say, find me major arc PE. So find the measure of major arc PE. While I finish typing that, you go ahead and do that. It should be real easy. So if PME is 100 degrees, you know that this whole entire thing here is a circle. So if that's 100 degrees, all I'm going to do is just subtract 100 from 360 to get my 260 degrees that make up that major arc, PE. Easy, you're saying. That's super easy. Give me a hard one. Well, okay, fine. We'll get a hard one. So again, whoop, wrong button there. Here's my circle. And now I am going to go ahead and say in circle O. You see O a lot for circles. I'm not really sure why. In circle O, I am going to again place 3 points here. B, A, and T. And I'm going to say that the measure of arc BAT is going to be equal to, actually no, I don't want BAT, I just did one of those. Let's do arc BTA. So BTA would be this big arc that goes all the way around through T to A. So that really, really, really big thing there is going to be 10x minus 20. So that is going to be the measure of that big entire thing. And I'm going to go ahead and I'm going to label that. A lot of times you're just going to go ahead and label it right on the outside of the circle here, 10x minus 20. And a lot of times what I like to do is I like adding a little line and just going like this around the thing. So I'm tracing it going, all right, BTA, that whole arc there is 10x minus 20. And then I am going to say that minor arc, that is not the way you spell arc, is it? Minor arc BA, its measure is going to equal, hang on, let me do it in my head, make sure I'm doing it right. That's good. 3x minus 10. Go ahead and find x for me. Okay. So I've gone, now I'm going to say, all right, this arc here, and sometimes I'll do a little double arc to differentiate it from the other one I did before. Sometimes you don't really need to do that. 3x minus 10. I see that between major arc BA and minor arc BA, I have a full circle. So their two measures have to add up to 360 degrees. So I'm going to break up my givens here, and I'm going to say 10x minus 20. And if I add to that 3x minus 10, I better get a full 360 degrees. So I'm just going to go ahead and solve for my x. That means when I combine like terms here, 13x minus 20 minus 10 minus 30 should equal 360 degrees. I'll add 30 to both sides to get that 13x is equal to 390. And then just divide by 13. We'll get that x is 30 or 30 degrees. Slammed right in there. Cool. All right. Now let's go to ones that don't really require a lot of math, but just require you to think a little bit. I'm getting so good at remembering, right as I was about to say, I'm getting so good at remembering the new controls of the software I'm running. I go and mess it up because that's just who I am. So I am going to have a circle here. This is going to be circle D for dummy, which is what I am apparently. And I am then going to draw in radius, or excuse me, diameter UM. So I might say circle D has diameter dm. There's my B. And I might say find the measure of arc UBM. Think about it for a second. So, if I want to know that, you might be sitting there saying, well, I don't have any other arc measures, angle measures in here. I'm stuck. Not quite. You know this thing's a diameter. So you know that this whole part over here, well, that's half of the circle, isn't it? And half of a circle is 180 degrees. So the measure of arc UBM is just 180 degrees. Anytime you have a diameter will create two arcs on either side of it. Both those arcs are going to be congruent. They're going to be 180 degrees. Simple, simple. Cool. Just looking at this, do I have enough information to get arc BUM or arc BU, the minor one here? The answer is no. I know nothing about this circle to get that. However, you might be told, oh, BU is 70 degrees. Find me the measure of arc BM. Once I have that, I'm able to go, well, I know that this whole thing here, MBU or UBM, that arc has to be 180 degrees. So if BU is 70, BM has to be 110 degrees. The same way, I can now say that arc BMU, and again, just like with angles and everything in geometry, order matters. These two arcs that I have here, UBM, BMU, use the same letters, but they're in different places. UBM goes in that order, whereas BMU traces out a much bigger arc. You need to be careful. The same way in angle, whenever we wrote out an angle, like if I said angle ABC, you always knew that B was the vertex of that angle. When I give an arc measure, arc PQR, the ends of the arc tell you where that arc ends. The letter in the middle just tells you what letter you're passing through. In other words, is it the minor arc or the major arc? So, BMU is the arc I want, and I want its measure. Well, I know that arc UM, no matter which way I go, is 180 degrees. So if I add on that 110, 290 degrees. And I can double check my work by saying, well, if BMU, this whole portion of my circle here, if that whole major arc is 290 degrees, and then I add on the 70 degrees, I get 360, which would be my full entire circle there. So I'm good to go. So those are just some very quick questions about arcs and their measures and things like that. Next, what we're going to start talking about is we've dealt with a few line segments inside of the circle. We're going to start seeing what happens when those line segments touch the circle, leave the circle, creating things known as secants and tangents. And we've got a lot more rules to learn, so buckle up. It's going to be fun. See you guys soon.